Okay, so we're coming to the final part of this little exercise of building a tree. How to apply the branching which we've just learned with split node. We get the node and split to left, right? How can we apply this repeatedly to the root node? So we'll give it a root, like whole data set, and somehow we need to be able to repeatedly apply it and create the tree. Before we do that, let's think about how do we represent the tree? What is going to be our tree, right? Because we need to think a little bit about the data structure. So let's think of what is a tree. Okay, so I'm going to write it as a text here. So what is a tree? So let's think of this. How do we represent the tree? So to represent the tree, we have we clearly we can do it sort of recursively in the following way. So think of a tree. So you can start from the root stump of the tree, and then you have the first branch and the next branch and so on. So we need to start somewhere, and this somewhere will have its own left and right hand sides. So I propose we do it the following way. This is not the only way. There's multiple ways of doing it. There are tons of structures for trees and so on. If you study computer science, I'm sure you'll find a better way of doing it. But I'll suggest one way which will probably work. Well, not probably, but definitely will work, right? So I'll say we have the nodes. They all kind of look similar, except some nodes are leaves, right? Meaning that they don't have any more branches. But some nodes keep branching. So let us find a way to represent them. So one way to do it would be the following. So if I'm looking at this tree, what I need to know about this tree is the following. I want to know the indices on the left and indices on the right if it's a branch. But if it's a leaf node, I don't need to know leaf indices left or right, but I want to know what are the classes, possible classes, and I want to know frequencies of these classes, right? So I want to know class frequencies, and then I want to know how to split this tree, and maybe all the indices of this. Right? So I spoke too much. Now let's see. So I'll say the following. So if it is a leaf node, right? So if it's a leaf node, I will do something like this. We will create it as a list, but the first, well, maybe not a list, maybe as a dictionary. Why not to create it as a dictionary? Dictionary, right? And dictionary is a class, not a class, but it's a data structure which has several components in it, which each one of them is named, right? So I will call this a dictionary with the following elements in it. So one would be the left hand side, right? So it will be called a left branch, maybe L branch, and then there will be a right branch. Why don't I just call it left or right, right? I can call it left, and I can call it right. What else? I have left and right class frequencies, right? Remember, my classes are outside. My data set x's and y's and classes are outside, because for the reason I told you, like if I can't keep them inside the node, because my classes if I have a pure node, there won't be any other classes, only one class. So I want to know what are all the classes, so I'll keep the classes separate, but I'll keep the class frequencies for this node, right? So I have the class frequencies, and then I'll have the split. By split, I mean how do we split it, right? So there will be, let's call it split. Okay, whatever, split. And then the final one will be indices, right? So indices of this leaf node. So if it's not a leaf node, if it's like a normal node, then I could do the following. So I'll have the same dictionary, right? Like this, left, right. So why don't we say it's a node, right? So the node is like this, but then If it's a leaf node, then this is going to be, for the leaf is none. Left and right are none, right? So left will be none, and right will be none. Class frequencies are always there. If it's a final node, split is not required, so split is going to be none. It's a leaf node, but indices are final node indices are a good idea to have, right? Now, if it's not a leaf node, if it's a node or like a branching node, right? Let's call it branching. Then we will do the following. It's a branching node, then left is not empty, right? There will be left-hand side. So if it's node like this, then there will be left-hand side and right-hand side. There will be left and there will be right. There will be some kind of a left node and right node, right? Class frequencies, I think, yeah, we need them anyways. But if it's a branching node, then split is not known, right? So there will be a split. If it's a branching node, then we don't need indices. This will be known, because the indices are in the left and in the right. So branching nodes indices are union of all the leaves. So if we're on this node, I don't need to know indices, because I know indices of the left, indices of the right. I can add them together, and that's my indices here, recursively, right? So that's fine there. I think, yeah, so we're good with this. So let's think of what is class frequencies. We can keep them in dictionary if we wanted, but we'll keep them. Class frequencies will be simply some sort of frequency set, right? Frequency 2, and if we have n classes, it's going to be n or whatever k. Let's call it n. Right? Class frequencies are here. What do we need? Split, right? So what is split? So split is going to be a dictionary also, and it will be a dictionary of column. So there will be a column, and there will be column, and what do the threshold of this column, right? Something like that. Threshold of this column. Okay. I think we mentioned more or less everything here. So, yeah. Oops, what did I do? Right, oh, I don't like this. So, formatting is important. Right, so this is my data structure. So basically, this will be my data structure for the method I'm going to create. So now, basically, I have the split node thing, but now I need to package it in a function which I can recursively call. So, for instance, I'll get my root and I will say make 2 branches, and then it'll make left and right, and then I'll say, well, keep branching on the left, keep branching on the right, which will recursively call again and say keep branching on the left, keep branching on the right, something like that. But it won't be a loop. It will be a recurrent call. So in order to do that, I needed this data set which I can carry from call to call. So that's why I am now at the final stage of this code, right, where I'm going to create this method, and which we will call maybe we already have split nodes, so let's call it make branches, right? So make tree or something like that. Make branches. The name doesn't really matter except for make branches. All right, we'll do it make branches. Which parameters do we need? We need x, we need y, we need the node to start, and then let's use hyperparameter max depth so that our tree doesn't keep growing infinitely, right? So the node is going to be this dictionary. And then using this dictionary, we will be able to keep branching it, right? So we call this make branches. And let's do this. So let's say we're asked to make a branch, but we already are at the max depth. So we are going to do the following. Then we'll say if max depth is equal to 0, then we will return this node, meaning we will not be splitting this node. So if we should stop splitting, then we will not be splitting this node. But if the max depth is not reached, then we will split this node, right? Split node, split node. Right, we need to modify this function, obviously, for our purposes, because this function doesn't work with a node at the moment, right? So this function works with indices here. So maybe we need to modify this function because it starts with xy and then it just goes into the indices. So let's do the following. We'll make a modification of this function. We'll create another one which works with, instead of indices, it'll work with a node as we defined it here. So how do we do it? We'll as usual, we'll copy it, we'll make it work, and then we'll delete the old one, right? Okay, so we'll call the split node, this one, this was a split data frame, right? It's not really a node, it's like a split all, basically. And we'll replace this with split node later. So instead of this one, we will be saying a node. And the node then, when we're calling this guy, the node will be the whole thing. So how do we create the node? We will say the node is a dictionary. Blah, 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 left, none, right? So left is none, right is none. Class frequencies are, should we be calculating them or not? Let's think about it. They are actually not that important in the beginning, so need to think a second. Yeah, we can actually calculate, why not? So we can calculate them as frequencies, right? Frequencies of y. And do we have all the IDXs here? So we start with the whole data set. We'll do this x index. Well, because the very first node, we actually don't need to do this. We can just say frequencies of y, right? And then split is known, is none, and indices are all the indices. So it's going to be x index like this, right? So we have the nodes. That's great. And right. Now we don't have indices, but we have the node. So how do we replace this guy? X and Y, node split. Split columns. Right, what we can do, instead of saying X index, we need to get index from the node. Because see, initially we're using the whole thing with the indices coming from outside, but now we want to switch to this new data structure, which I just suggested. So now we need to use only these variables, nothing from outside. If we say x index, then we'll make the split node dependent, like always splitting the whole thing, but we don't want to always split the whole thing, we want to only split the node. So that's why we will say node, and then in the node there is a value which corresponds to an index, right? IDX. So we know node, and then we want IDX, right? That's F is X columns, that's fine. So this should work, I think. So why don't we try it? Okay, it didn't work, something classes, okay. Right, because here we need classes. .26, yeah, so they're producing exactly the same output. Great, so I can now remove this first version of split all, right? So because now we have a luxury of having the data structure like this, right? So let's run it and see what happens. Okay, great. So here we will say data structures. Data structures. Right. Good. That was data structures. Good. So now we can work with these make branches, right? So we have this make branches XY node, max depth. Okay, now we should be able to call this XY split node function, right? What is it suggesting? XY node, that is great, right? So when we split the node, that's fine. We get the left and right hand side, right? So let's see. Right, so we should be now able to create two. We run this thing. Okay, so what is the output of split node? So let's see. Our split node returns several outputs. We get all these outputs. Right. Okay, we don't need to call them cost min or anything, just cost column. So in the very first split, we got the cost, we got the column, we got the threshold, and we got the node split. Now we want to keep calling this make branches after on the left hand side and on the right hand side, right? So we want to call again recursively the same function, as crazy as it sounds, as follows, right? But the depth now can be only one less, right? Because we started with max depths when we came to make branch, and if we keep branching, our depth should be less and less, and at some point we'll hit 0 and stop, right? So that's why the branch here is going to be the following, right? So make branches. Did we not do something here interesting? Okay, I think we're fine. So, okay, so we do this, right? Max depth is equal to 0, return node, cost, blah, 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 split node. Great, right? So one less branch, but the node now is not the same node. We need to apply this on the left and the right-hand side of this node, right? So how do we do that? So let's think about it. We are going to do the following. Our node had the left side, right? And the left side is going to be left, and it should be equal to node split node split. But then if you remember in the node split, when we created the node split here, where is it here? We had left index left frequency and right index right frequency. So that's why we are going to do this. On the node to the left, we will create a new dictionary like this. So we will create a new dictionary like this, which is going to be the left-hand side of our node, right? But we are going to do the following. Okay, we will start it as leaf node, left, right, but class frequencies are going to be already calculated frequency, right? It's going to be from node split, left-hand side, and then if you remember, it's going to be the first one. It's frequencies, right? And then the split one is going to be, what did we decide on split? We said the split is going to be a dictionary too. So we will say it's also a dictionary. And this dictionary's column is going to be equal to, how do we do this? All right, so this dictionary's column is going to be equal to column, and it's TK, this dictionary's TK, is going to be equal to this node splits threshold. Remember, we actually no, this should be empty. This node split should be none for starters, right? So it should be none. I apologize. So split should be none, and the index should be the left-hand side index, which is node split 0. And then for the right one, AI suggested me to do the following. Dict good, but then it will be right. Oh, wait a second. These are all empty, that's fine. Empty. Right, so what's going on? Class frequencies node split 1, 1, split is none, index node split 1, right 1, right? So because the index on the right hand side, when we created this data structure, you see, for the left hand side we get indices and frequencies. So that's why when we need frequencies we get 0, 1 element. When we need indices, 0, 0. When we need right hand side index, it's 1, 0. And when we need right hand side frequencies, it's 1, 1, right? And that's what we are doing here. Right, but then for the node itself, the nodes split, right? Split is going to be I'm using AI suggested code. Let's see, is it right? Column, T call, TK. That's good, right? Because we said we'll call it column and column. So it's somehow it's guessing my code. So for split, I did it. For frequencies, did we do it for frequencies when we did the node split? So actually, we could modify it right here, right? So when we were doing this, why are we not modifying it right at the spot? You see, when we're returning this stuff, but we didn't modify node, why don't we modify the node then? We could, right? Do it right there. So it seems like this piece of code actually belongs to the function itself. Once we split the node, it seems like we need to modify the node right there. Yeah, I think we should modify it right there inside the node. Makes me think. Yeah, I think we do it. So we do it right here, right before the return. We will modify the node split. So we got this node, we calculated everything. Why don't we just modify it right here, right? So for this data structure, you see, once we calculated the node, we know it's a branching node. So we should be able to now modify class frequencies and split. And indices will be none from here on, right? Because we already returned the indices on this stuff, right? So we will do exactly that. We will say split is this, left and right, and then the final was this indexes, we'll put it at none. Yeah, I feel good about it. So we will say node IDX is none. Great. Class frequencies. Do we need to do this? I think so. Yes, I think we need to do this too. Well, actually, we already calculated class frequencies, so we do not need to do. When we created the node and passed it, we already did the class frequency, so we don't need this. So let's just test that and see we didn't break anything. Right, it doesn't look like we broke anything at this point. Right, that's good. So now we can get to our make branches. So it was a little cluttered. Now it's clean. We split the node. Once we split the node and return the outputs, this whole thing, split node, is going to, the node is modified here, right? Once we run the split node, the node itself is modified. That's actually important because now what we're going to do is when we run the make branches, we will run the make branch on the left hand side of this thing because it's already modified, right, with max depth, and then we'll run it on the right hand side. Wait a second. Make branches XY right hand side. Make branches, and we should be done by this, right? If it worked, we'll just return our node. We don't even need to do this, but we can, right? So how do we test this? So let's test it. The way to test this, we'll start with a root node like this, and then actually this node, right? This is the root. Right, so why don't we just say this is the root, and then we'll call this a root. Let's see if it still is working. Now we will apply it to the root, and we will do the following. We'll say print root. Well, actually, you know what? We probably need to recreate it because after you run it a few times, it keeps changing, right? So we'll do this. We'll create the root right here. We'll copy it. And then we'll print it, and then we'll print the result. We'll call the result. And then if everything worked, we should be able to make branches. So I'm saying max depth is 2, x, y, and root. And yeah, the output of this make branches is the node itself. So we should be able to print it. So let's pray this works, because if it doesn't, then we'll have to debug it. Well, it didn't work, so we have to debug it.